All right, ladies and gentlemen, this is the second video of this assignment. In this video, I will be going over numbers 4, 5, 6, and 7. So if you haven't watched the previous video and you're stuck in those problems, I recommend you look at that video. Let's go ahead and continue. Number 4, a geologist is going to ship 2 granite specimens to a university. The first specimen weighs 27 pounds and the second weighs 19 pounds. The shipping crate weighs 4 pounds. The shipping crate is what percentage of the total weight of the shipment? Okay, so let's look at the important information. So the geologist is shipping 2 granite. You don't have to know what that is. It's basically 2 rocks that they're going to study at the university. The first specimen, first weighs 27 pounds. The second weighs 19 pounds. So they're going to have to ship these 2 things. So that's adding on weight. And finally, the actual crate that those rocks are in weighs 4 pounds. Okay. And the question is asking the shipping crate, so just the crate, the 4 pounds, is what percentage of the total weight? So notice, ladies and gentlemen, that it's asking for the percentage, which we know a percent is always a number over 100, which we obviously don't know what the percent is. Otherwise, it wouldn't be asking, well, what is the percent? What percentage of the total weight? Do we know the total weight? We don't know it, but we can figure it out, right? So let's first figure out the total weight. To figure out the total weight, we need to add up 27 plus 19 plus 4, right? That's going to be the weight of the entire shipment. So this is 13 plus 7 is 20. Right? And then 4, 5. So that's 50 pounds. All right. So we have our total weight, which is 50 pounds. And we're interested in the shipping container, which is 4 pounds. And it's asking what percent, remember a percent is always a number over 100. What percent, a number over 100, and we need to know what that number is. In other words, X. Ladies and gentlemen, this is another one of those. There are several ways of doing this. I'm just going to help you set it up here, ladies and gentlemen, and I want you to figure it out on your own. If you still need help, let me know, but this should be enough for you to move on. Notice how I organize the information. All right, moving on. Number 5. Principal Ramos observed that 1/1800 of the students at her school walked to school each morning. Which percent is equivalent to 1/1800? Which percent is equivalent to 1/1800? Notice how we're starting with a decimal. We want to change that to a percent. So ladies and gentlemen, what is our favorite fizzy drink? We know that it is Dr. Pepper. DP, which is decimal, and percent. Notice that we are starting with a decimal and we want to change that decimal to a percent. So we have to move the decimal over twice towards the P. We have to move it to the right. So figure out what percent that is. That's pretty simple. Hopefully you can figure that out. Moving on to the next one, ladies and gentlemen. This is number 6 now. Number 6, at Arcade Palace, a child can buy 16 video game tokens for $4. At Alibaba's, a child can buy 10 tokens for $2. Which statement is true? So we have 2 different places here. So Arcade Palace, and you can buy 16 tokens for $4. And then we have Alibaba's, a child can buy 10 tokens for $2. And we want to know which is true, which I think without having to go through each answer choice, I want you to do that. Let's figure out what's the better deal. In other words, what's the best cost per token? What's the best cost per token? Usually when you're dealing with money, you want to always find out the cost in dollars or pesos or whatever, the cost per item. So in this case, the item is token. That's called the unit price, or price per unit. That's how you see at the store what is better. You know, what's the cheaper option, assuming that both are comparable. So Arcade Palace, you notice that we have tokens and money. Tokens and money. So 16 tokens. So I put tokens on the denominator. It really doesn't matter. But I recommend that you always do cost per money. You want to know the cost for one token. Cost for one token is $4. So $4 for 16 tokens, but we want to know the cost for one token. All right, the cost for one token. So in other words, what do we have to do to 16 to get to 1? Well, obviously, you can divide it by 16. You can divide it by itself. And I realize it's going to give us a decimal, but that's fine. That's totally fine. So 16 divided by 16 is 1. 4 divided by 16. So let's go ahead and do that. Which, well, whatever. So 4 divided by 16. 4 divided by 16. 16 can go into 4 0 times, but it doesn't go into 40 twice, and that's going to be 32. And that's going to be a remainder of 8. That doesn't make sense. Oh, yeah, no, we're good. All right, let's keep going. So let's bring down the 0. And 16 can go into 80 exactly 5 times, I believe. Yeah, because that's 530. Yeah, so it's like 25. So in other words, it's going to be 25 cents for one token. 25 cents for one token. That is at Arcade Palace. Does that make sense? So again, all I did is I divided 16 by 16 to get to 1 and 4 by 16 to get so it's 25 cents per token. So ladies and gentlemen, you do the same. Now do it for Alibaba's. We're at Alibaba's. Again, we have the cost. We have the cost for each token, and the cost for each token is $2 for 10 tokens. But what is going to be the cost for one token? And a huge hint, if you divide 10 by 10, that'll go back to 1. So divide 2 by 10 and see what is going to be the cost for one token. And ask yourself, what is the better deal? 25 cents per token at Arcade Palace, or what's the cost, which is going to be a decimal. 2 divided by 10 will be a decimal. For one token at Alibaba's. And hopefully, knowing that information, you'll be able to answer these questions. Okay, let's go on to the last one, ladies and gentlemen. The last one, which is number 7. Number 7. Notice how they give us an equation, or rather an expression here. There is no equal sign. So we have -6. I recommend you start off by rewriting it. Minus -3. Now, ladies and gentlemen, we've talked about this before. We do not like to subtract with negative numbers. And we don't like to subtract when we're taking away more than what we have. In this case, we're dealing with negative numbers. So let's apply our rules. Keep, change, change. Change this to addition. Okay, change this to addition. I promise you it's going to be a lot easier. In which case, we know that we are now starting. We're starting with -6. We're keeping the -6, and we're going to be adding +3. So it's just the same thing as -6, and then we're increasing it by 3. So which of these number lines shows us that we're starting at -6, and then we are increasing it from the -6, then we're increasing it from there by 3. All right, so hopefully that's enough, ladies and gentlemen, for you guys to be able to solve this problem. If you guys have any questions, ask me in class. With that in mind, I will see you next time.